Casimiro. Not Casimiro. Not here. Rogelio. Describe for us some things you see from t of x. So this is the parent function, child function. Just give me one observation. So your d, you're saying, so that's on the outside, right? And you said up 4 units. Raise your hand if you got that. So that's one of them. D equals 4 on the outside towards the right. Remember, use that formula so you can just like literally line it up like I'm doing. It's outside the parentheses to the right, so that's your d value. Good job, Rogelio. Daniel, tell me another one. C value is 2. You are correct. It's on the inside. Remember, if you need to, you can write the formula right above it to identify them. All right, what does that mean, Daniel? You tell me. Are you going left or right? Is 2 bigger than 0 or smaller than 0? So left or right? Right, 2. Did you guys see how I did that? Your C value is 2. Then I'm just looking on my chart. Is it bigger than 0 or less than 0? 2 is bigger than 0, so you're going to the right 2 units. Good job, Daniel. Trisha? Last one. Shh. Okay, what value is here? Trisha? A equals what number? You have to put a number there, right? Your choices are 0 or -1. -1. What does an A value of -1 tell us, Trisha? Is it bigger than 1, between 0 and 1, or less than 0? Less than 0. What does it tell you? Reflect over the x-axis. Okay, raise your hand if you got that. Okay, so this should just be a review, and then you could use this and make a rule, right? It didn't ask us to do that, but it did ask us to. Number 2, write an equation. Okay, this is the new part. Let's write now an equation. So it tells us write an equation for t of x in terms of x. What does that mean? Start with t of x. So start at t of x. I'm going to write down t of x first. T of x is equal to negative p x minus 2 plus 4. Okay, everyone say double substitution. Double substitution. Okay, here's the first substitution. I'm going to use 2 different color highlighters. Hopefully you can see it, but this is the best way I can describe it. My p value is x to the third. So I'm going to write x to the third. Now, here is the second substitution. Instead of placing x here, I'm going to be putting in x minus 2. X minus 2. So this is what I have. The opposite of x minus 2 cubed plus 4. Let me explain it one more time, and I'll explain it in an alternative way. I see P, and this is my first substitution in yellow, because P is x to the third. But then it tells me for every x value of P, we're going to put in x minus 2. That's the green. Okay? Here's another way of describing my substitution. You're basically putting in x minus 2 into this x value. Then you're going to take the opposite of it and add 4. Okay, so it's kind of like the parent functions, right? So if I showed you pictures of my kids, you're like, oh yeah, Mr. A, like the ears look similar to your kids, and the eyes, but oh no, the facial features, like the nose, that's like your wife's facial features. Does that make sense? Okay, let's go ahead and simplify this now. This was like the number one mistake on your chapter 1.1 test. A lot of students thought, I can distribute the 3. Everyone say no. You can't do that. So when in doubt, write it out. When in doubt, write it out. How many of these x minus 2's do I have? 3 of them. What does this mean? I'm going to have to use the box. The box. So I'm going to write out x minus 2, x minus 2, and essentially this is FOIL, right? Class, we're going to multiply, then we're going to add. Multiply, then add. Class, what's x times x? X times negative 2. Negative 2 times x. And negative 2 times negative 2. So, in pink, let me draw this pink line again. What's our answer? When you combine like terms, what do you get? X squared minus 4x plus 4. And I'm just going to drop all of this. It gets better. Now I have to multiply a trinomial times a binomial. Look at this thing. X minus 2 so x minus 2, and then this in pink, x squared minus 4x plus 4. Let's take a processing break. Okay? Partner A, I want you to explain how did we do the describing and the double substitution. Partner B, you're going to explain also the double substitution and how we got the pink, and then you guys are going to work on the purple together. Okay? Ready, set, go. Benito. Why you? Because you'd like to talk today. Benito, multiply. Yep. Yes. 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 Good. Raise your hand if you got that. So to review, you are multiplying first, then you are adding. Okay, so hopefully you're following along with my colors. So I still have the negative sign, and I still have that plus 4. Alright, Peter, help us combine like terms. We're going to add now. Which ones are like terms? Or tell me what to write in the purple. Yep, you are correct. Correct. Notice how he's only adding the numbers in front when you're adding, right? And then you have what? x cubed minus 8. Now the neat thing about using this area model, as long as there's no missing terms, the like terms you'll notice are going diagonals, especially if it gets a little bit bigger. Okay, good job, Peter. Now we have to distribute, class, what number's out here? Negative, right? -1. So you can think of it as multiplying by -1 or just changing all the math operations inside. So Annalyn, help us multiply that -1. Yes. 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 Plus 8. And then Annalyn, now we're just going to add those two together. 12. This is a huge polynomial in standard form. So let's review what we did. We described the transformation with letters and numbers and words, and then we wrote an equation, t of x, in terms of x. So we did double substitution in yellow and green, and then we just simplified.
I love math. You don't love math? What's wrong with you? I love math.